Now that we've talked about using row reduction to compute determinants, now we're going to talk about using a process called cofactor expansion, or expansion by minors, to compute determinants. So to this end, let's look at the determinant of this matrix that's on the screen. Now, we could go about doing this by row reduction, just like we have in class. However, we're going to take advantage of some properties of this particular matrix that are going to be more useful for us to be able to calculate this determinant. In particular, look at this third column. This third column has 3 zeros and a -1. So we're going to do what's called cofactor expansion. We're going to expand along this column and create a new set of determinants to compute that will also be equal to the determinant of the matrix that we're given. Now, the actual definition of the determinant function from what's referred to as a combinatorial approach, you'll see this in section 2.4 of your textbook, is a sum of signed, either positive or negative, permutations in the matrix. All that means is we're going to do all possible products of entries from the matrix. We're using an entry exactly one time from each row and each column. So for example, one of those products would be 5, -1, 0, 20, because we used row 1, row 2, row 3, row 4, and similarly with the columns, exactly one time. Another permutation would be 6, -1, 0, -6, and we would do those products. That's another permutation. The signing is just a matter of, is it a positive permutation or a negative permutation, which we're not going to be all that concerned with for our purposes, because we're not going to go through that combinatorial approach. But the idea is for determinants, you want to do all the possible products you can in this fashion. Turns out when you do row reduction, basically all you're doing is regathering those products in a certain form to be able to do the multiplication. This is just another way to regather those particular products. We're going to have some helpful products, in particular multiplication by zeros and ones, which will help us do the products even faster than what row reduction would be. All right, so we're going to do what's referred to as expand along this third column. So to do this expansion, we also need to keep track of positive and negatives, like I mentioned. So I refer to this as a sign board. The sign board starts with a plus up in the upper left-hand corner, and then as you go down any column or across any row, the signs alternate. So just start with a plus sign. As you write across, you put positive, negative alternating. As you write down, positive, negative alternating. One thing you'll notice about this form is that if you go down diagonals, the signs don't change. So down the main diagonal in particular is always positive. So you'll know that you've figured out, that you've written this down, correctly, if you've got your signs in this particular order. If you see this nice pluses down the diagonal, you've done your alternating correctly. All right. This just help us keep track of, is the permutation I was just talking about, the signed permutation, is it a positive permutation or a negative one? So we're expanding along the third column. So we're going to use this third column of signs to help us keep track of the signs. So what this means is that with this 0 up here in the row 1, column 3 spot is assigned a positive. This one is assigned a negative. This one is assigned a positive. And this one, again, assigned a negative. So we use these now as the coefficients for new determinants that we'll make in the following manner. All right, so it was a positive 0. So that's why I just have a 0 here. And then we multiply by a new matrix, or the new determinant, pardon me. Now this is called the minor associated with this entry. And here's how we get it. So this 0 came from this spot in row 1, column 3. So we eliminate row 1, eliminate column 3, and write down the 3 by 3 that's left. 1, -1, 0, 10, 2, 15, -6, 7, 20. We're going to do that for each of the other entries in this third column. The next 0 is a negative, so that's why I have -0. The minor associated with this is 5, 7, 6, because we have to eliminate this third column again. So 5, 7, 6, eliminate row 2, 10, 2, 15, -6, 7, 20. Third one is a positive. And then again, we eliminate row 3 and column 3. So 5, 7, 6, 1, -1, 0, -6, 7, 20. The last one here is a negative of a negative 1. So minus a minus 1, and again, eliminate row 4, column 3, 5, 7, 6, 1, negative 1, 0, 10, 2, 15. So this is the expansion by minors. So each of your minors goes down by a dimension. We started with a 4 by 4, so each of the minors is 3 by 3. We have coefficients out in front that do multiplications. Now notice again, though, we picked this particular column, the third column, because it had zeros and ones in it. Notice that 3 of them were 0, so I don't have to do any of these. And this multiplication here, minus the minus 1, becomes a plus 1. So this determinant that we started with of the 3 by 3, or excuse me, the 4 by 4, now turns into this determinant of the 3 by 3. So another convenient row that we might want to multiply or expand along for this one is this third row, because again I see ones and zeros. So first off, if we go think about the sign board, remember the sign board starts with a plus sign and it alternates down with negatives and then a negative positive, and then the same with the cross. So this first one will be a negative 1. We eliminate column 1 and row 2. The minor is 7, 6, 2, 15. This negative 1 has a plus sign with it, so it's plus negative 1 times, and again, row 2, column 2 eliminated, 5, 6, 10, 15. The last entry is a 0 in that row, and we have 5, 7, 10, 2 for the minor entry. Notice the first case we expanded along a column, the next case we expanded along a row. That's okay. Remember, we're just trying to keep track of products, and we're doing the products in a certain way so that we can take advantage of multiplications by zeros and ones as much as we can. All right, so this one goes away. Both of these are negative. And now we have 2 by 2. And then when we're 2 by 2, we have the easy case, because we can do the determinant easy. Multiply down the main diagonal, subtract off what we get when we multiply the off diagonal. So the first one is 7 times 15 minus 2 times 6. There's a negative sign hanging out in front. This is 5 times 15 minus 10 times 6. Again, a minus sign hanging out in front. And we get negative 108 for the determinant. This cofactor expansion, the expansion by minors, is a very, very helpful way to calculate determinants if you've got rows or columns that have lots of zeros and ones in them, because those multiplications are easy. If you've got a matrix full of non-zero entries that aren't zeros and ones, row reduction is probably still your best bet, because you're going to be doing lots of different multiplications, and it's not taking advantage of being able to multiply by zeros when we can. Let's just do another quick example to see if we can do another one here. So here's the matrix we want to take a determinant of. We notice that row 4 has 3 zeros and a negative 1. Again, with the sign board, we would start with a plus sign up here, be plus, minus here, and then plus, minus, plus. So our signs on our coefficient are going to be minus, plus, minus, plus. The only thing that survives, because remember, these are the coefficients we're multiplying by, so there's no reason even to write them down. The only thing that survives is the negative 1, and it has a minus attached to it, so it's minus a minus 1. Eliminate column 1, row 4. Here's our minor entry, negative 2, 1, 6, 0, 2, 0, 8, 3, negative 5. Now again, I notice that this row has a couple of zeros in it, so I might as well take advantage of that. This 2 is on the main diagonal, so it's assigned a plus sign. So 2 times, and then the minor entry assigned with 2 is negative 2, 6, 8, 5. Again, I don't need to worry about the other 2 because they're multiplications by 0. We've boiled this down now to a single 2 by 2 determinant, which is easy to compute. Negative 2 times 5 is negative 10, minus 6 times 8 is 48, and we get negative 116. So again, computing determinants by cofactor expansion, or what we refer to as expansion by minors, is convenient if we have a row or a column with lots of zeros and ones in it, because those multiplications are easy to do.